Okay, we're going to finish up this problem this time. So we got started on it in the last video. We're trying to find the dimensions of an open rectangular box of maximum volume. So that's what we're trying to maximize, is volume. That's made from a sheet of cardboard, 13 by 8. The secret is to let x be the length of one side of one square that you cut out, because then it's pretty easy to write all of the dimensions of the entire box in terms of x. So if you let that distance be x, and this distance is x, and this whole side is 8 in my example, then this green part, what's left, is actually 8 minus 2x. So that's I'm writing it as the shorter side of the box, the width maybe you'd call it. The longer leg of the box right here would be this whole length, 13 minus that x and minus that x, 13 minus 2x. And then the height is this x after you fold up these four sides, 1, 2, 3, 4 sides, right? You fold those up to make a box. And you just cut out these squares. Those are not even a part of the box, okay? Or maybe you use them to glue it together, I don't know. But okay, so there's our box. And we want to, right here, maximize volume. So that's our objective function, is volume. Volume of a box is length times height times width, or length times width times height. So in this case it would be 13 minus 2x times 8 minus 2x, all times x. That's the thing we want to maximize. It's already all in terms of one variable, so I don't need a constraint because of the way I did it. Now you could have used, 2 or 3 variables here and then had a couple of constraints, maybe like L for length and width for W, and at this point, then you would have to use those constraints to get volume in terms of one variable or the other, but I've already got it all in terms of x. So this is what I'm going to differentiate. But if I leave it like this, I've got to use the product rule twice because we have 1, 2, 3 factors. I'm not even sure we ever did an example like that of using the product rule twice. We may have, but I'm not certain. If you do it that way, you would basically have to group 2 of them together, maybe like that. So this would be your first factor times the derivative of this factor, which would involve the product rule, plus this factor times the derivative of that factor. I think that let's go ahead and distribute first. So let's do one part at a time. First, let's take the x in, and then we'll FOIL. So 13 minus 2x. Now you could multiply the x into this factor or into this factor, but not both, right? That wouldn't make sense. So I'm going to multiply it into this one. So 8x minus 2x squared. And now I'm going to FOIL that. So let's see. Let's get out our calculator here. So 13 minus 8 isn't something I want to do in my head. There we go. So 13 times 8 is 104. Okay, 104x. FOILing, then 13 times 2 is negative 26x squared. Inside term, minus 16x squared. Last term, negative 2x times negative 2x squared would be positive 4x cubed. And then I can combine my 2 middle terms. Negative 26 minus 16. Let's do 26 plus 16 is 42. So negative 42x squared plus 4x cubed. Okay. Oops. There we go. Now we can differentiate now that it's fully simplified. So the derivative, actually I'm going to move it over here. Why not? So v prime would be 104 minus 42 times 2 is 84, x to the first, plus 12x squared. Okay, so it's a quadratic. It exists everywhere, so we look for critical values where it equals 0. Let's see what I can take out of 104, 84, and 12. Now I know 84 is divisible by 12. I don't think 104 is. But let's see what we get. Let's see, I know 104 should be divisible by 4. Yeah, which is also divisible by 2. Maybe it's divisible by 8, but 12 is not. So let's just take a 4 out of everything to make the numbers a little smaller. I'm also going to rewrite it in standard order. So I'm going to put the 12x squared term first. I'd have 3x squared. Then this term next. 84 divided by 4 is 21. So minus 21x plus 26 equals 0. And ooh, that looks like it's not going to be fun to factor. But we're going to try factoring and see if we can. And it may not. We may have to go to the quadratic formula here. So see, 26 is only really divisible by 2 and 13. I want to get a 21 as my middle number. Let's try a 3x here and a 1x there. Now, if I was to put a 13 here, then I would end up with 13 times 3, which is way too big. So I'm going to try putting a 13 there and a 2 there. See, everything has to be negative, so that they add to a negative, multiply to a positive. So I get negative 6x minus 13x. That does not work. I don't think this is going to factor, to be honest. 26, I'm not seeing it. If I did 26 and what now? Let's just use the quadratic formula. Okay, so quadratic formula, I'm going to divide both sides by 4, that goes away. So x equals negative b, so it would be positive 21, plus or minus the square root of b squared is 21 squared. Let's go ahead and see what that is. It is 441 minus 4 times a times c all over 2a equals 0. Okay. Now let's simplify this. So under the radical, let's simplify that part. So I've got 441 minus 4 times 3 is 12. So 12 times 26. That should do it in the right order because it'll do multiplication before it does the minus here. So 129 is what I have under the radical. I just want to do a double check. 26 times 21 is 546. Oh, no, it's because I can't read. Okay, 26 times 12 is what I'm trying to do. 312. So yeah, that's right. So we get 129. Okay, under the radical. So 21 plus or minus the square root of 129 all over 6. Now I don't know off the top of my head. I suspect that might be prime. In other words, I don't think this is going to simplify. And we're going to have to round anyway. So let's just go ahead and round these two numbers. See what we get. So for the numerator we have 21 plus the square root of 129 divided by 6 is approximately 5.39297. 39297. 5.39297. Or if we do the minus 21 minus the square root of 129, this is probably going to give me a negative answer, which won't make sense. Let's see. Oh, nope, it's still positive. That's amazing. Okay, so okay, so 1.607. Okay, let's see if both of those x's actually make sense for the problem. I should probably carry that out a little bit more. How about 1.60703? There we go. Okay, so if x was 5.3, 5.4 roughly, let's go back to the diagram. If x is 5.4, that actually doesn't make sense because you can't cut away, if this whole side is 8 inches, you can't cut away 5 inches here and 5 inches there. You don't even have that much material. You'd be cutting away almost 11 inches out of only 8. So That answer doesn't make sense in this problem. It's too large. In fact, which reminds me, we need to go find the interval for x, which we'll use this diagram here to figure out. What is the smallest x could be, which I suppose would be 0. And the largest, let's see, if you're cutting away squares here, that's x and that's x. And this side is 8, then it looks to me like the biggest x could be would be 4. Okay, and that one x we did get is in between 0 and 4, so that makes sense. So what we need to do is find the volume when x is 0. I didn't write that right. Volume when x is 0, volume when x is 1.60703, and volume when x is 4. Now your volume, if you don't even have a side of the box, like if x is 0, you're not cutting anything away, you have a flat box. So volume when x is 0 would be 0, which you could also find by just plugging in 0 right here into V. If you plug in 4, you also have no box because you have cut away the entire side here, so it would fold up flat. If you plug in 4 here, you should get 0. Okay, so then volume when x is 1.60703, you would plug into here for V. I'm going to let you guys do that, but that's how you would find the volume. Then to get the dimensions, so we've got one of the dimensions, 1.60703. So to get the other two, we come back up here. The width is 8 minus 2 times 1.6, and the length is 13 minus 2 times that value. And then you round to whatever my math lab tells you to round to. So I hope that helps you out on this problem. Let me know if you have any more questions.